I don't think there's a lot that's going to give you trouble in section 2.1. I just want to review the distance and midpoint formula and show you a tricky problem I dreamed up using this, based on something I saw in the homework. So let's talk about the distance and midpoint formulas in the xy plane. Let's suppose I got 2 points in the plane. This one, its coordinates are just going to be called x1, y1. And this one I'll say its coordinates are x2 and y2. What's the distance between them? Well, the trick is to think about a triangle. So I'll draw this triangle here with horizontal and vertical legs. Since that's horizontal and vertical, these two legs meet at a right angle. That's a right triangle. And in this picture, that distance is, well, this vertical distance is the vertical distance from this point to that one. That's got nothing to do with the x's. It's just the difference in the y's. So I guess in this picture it's y1 minus y2 because I can tell from this picture that y1 is bigger than y2. And this horizontal distance is, well, x2 is bigger than x1 because x2 is to the right of x1 in this picture. So that distance is x2 minus x1. So what's the distance? Well, it's the hypotenuse of this right triangle. The distance squared must be y1 minus y2 squared. Must be the sum of the squares of the legs of the triangle. So that distance I'm looking for must be the square root of that. Look where I wrote this. I put the x's first. I don't know, I think I should write things alphabetically. That's probably kind of pointless, but I wrote x1 minus x2 here and x2 minus x1 there. Did I make some kind of a mistake? Well, no. And it's not because x1 minus x2 and x2 minus x1 are the same. In fact, they're exact opposites. x1 minus x2 is negative 1 times x2 minus x1. But that means they have exactly the same square. So in fact, it doesn't matter where y1 is bigger than y2 or whether x1 is bigger than x2. If I write down these differences and square them, I'll get the square of those distances in the right triangle. I should also warn you that the square root of a sum is not the sum of the square roots. I can't take the square root of this guy and the square root of that guy separately. But what about the midpoint? The midpoint is exactly what it sounds like. It's the midpoint of the line segment that joins x1, y1 to the point x2, y2. So look at these green lines. I drew a green line to indicate these different x coordinates. There's the x coordinate of the first point. There's the x coordinate of the second point. Well, look at the green line for where the midpoint would be. It's got to be dead center of x1, x2. The x coordinate of the midpoint has to be the average of x1 and x2. And the blue lines are trying to tell me that the y coordinate of the midpoint has to be the average of the y coordinates of the 2 points. So the midpoint formula is that the midpoint is a point, and its x coordinate is just the average of the x coordinates, and its y coordinate is the average of the y coordinates. Let's try an example. Here's one of the more challenging problems in this section. Let's suppose xy is some point in the plane. It's 2 units from the point 1, 0, and that the y coordinate of this point is equal to 2 times its x coordinate. Find the point. Sometimes drawing a picture gives us an idea of what calculations to make. Here I don't think the picture helps so much. Let's think about what this says in terms of x and y. So you think of x and y as being 2 variables. You must have a couple of equations in order to, involving x and y so that you can learn what they are. So one of them is right here, that xy is 2 units from the point 1, 0. So the distance from xy to 1, 0 has to equal 2. But there's a distance formula for that. It's the change in x squared plus the change in y squared, square root thereof. That has to equal 2. If I square both sides, the equation gets a little easier, so let's do that. X minus 1 squared plus y squared has to equal 2 squared is 4. So there's one equation in x and y. Right there's the other. Y has to equal 2x. So this is nice, this equation's already been solved for y. Let's just take that y and substitute it in here. Now the equation becomes x minus 1 squared plus the square of 2x equals 4. Okay, you know, the square of a product is the product of the squares. This is the same thing as 2 squared times x squared. That's because there's a multiplication in there, not an addition. That's just one of the old laws of exponents. But now see, this will be a quadratic equation. If I FOIL all this out and collect up terms, I'll just have some x squareds and some x to the 1s and some constants. So let's do that. That's a perfect square, so I don't even need to write it out. I know that's x squared minus 2x plus 1. The first thing squared plus the last thing squared, and 2 times the product. And then plus 4x squared. That's to equal 4. How do you solve a quadratic? You get a 0 on one side, and you factor the other. So I'll collect these like terms. 5x squared minus 2x. I'll subtract the 4, so minus 3 is 0. I want to factor that. I know the only way to get a 5 is to use a 1 and a 5 for the x coordinates. And the only way to get a 3 is to use a 1 and a 3. And if I want a 2 in the middle, I think I want the 5 to multiply the 1 and the 1 to multiply that 3. So this 5 has to multiply the 1, and this 1x has got to multiply that 3. That'll give me 5x and 3x. They have to be different signs here to get negative 3. I think to get minus 2x, this has to be a minus, and this has to be a plus. There we go. So x is 1, or 5x plus 3 is 0. X is negative 3/5. Are we done? Look carefully. They said find xy, find the point. So y is equal to 2x. So the point they're talking about here, when x is 1, is 1 comma 2, because y is 2x. But here when x is negative 3/5, it's negative 3/5, and if I double that, I get negative 6/5. Now we're done. In fact, there were 2 different points that satisfy these conditions. 2 points that are 2 units away from this point and satisfy that extra condition.